Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 66 of Physics 5054. In the last lecture, ladies and gentlemen, we were discussing the concept of evaporation. We also differentiated between the boiling point and the evaporation. Evaporation can take place at any temperature while boiling point is always taking place at fixed temperature. Uh, Ladies and gentlemen, today we are going to discuss the factors affecting the evaporation rate. There are many factors which are increasing the rate of evaporation, and there are many other factors they are decreasing the rate of evaporation. Ladies and gentlemen, let us discuss those factors one by one. First, I am starting from the temperature. Remember, ladies and gentlemen, that evaporation can take place at any temperature, but increasing the temperature of the surface of the layer of liquid increases the rate of evaporation. For example, if you are putting clothes in the sun, so the temperature increases and the molecules at the surface of the clothes getting enough energy to escape out from the surface of the clothes, and as a result we are being able to see that clothes become uh, dry very soon in the temperature. If the temperature is decreased, then evaporation also decreases. You can see on the rainy day or the cold condition, when the temperature is low, the clothes are not getting very soon dry because the temperature is low. So one factor that is affecting the uh, evaporation rate is the temperature. Temperature is the greater the number of molecules in the surface layer are energetic enough to escape out. That is what I told you. Number second is the humidity. Whenever we are talking about the humidity, we mean that there is a greater amount of vapors available inside. The air is high. Ladies and gentlemen, humidity also affects the rate of evaporation. If there is a more humid environment, you will observe that the clothes are not dried very quickly because the water vapors of the air is making the condition damp, and in the damp condition the evaporation rate is slow. On the other hand, if the humidity is low in the surrounding air, then it will increase the rate of evaporation, and as a result we will be able to see the clothes are wetting very quickly. Uh, if you are sitting in an air conditioned room, the air condition is reducing the humidity inside the room, and when the humidity is less, your skin and your throat are looking very dry, and again you want to drink the water. So the converse phenomena is also true. When the humidity is less, the evaporation will be more. When the humidity is more, the evaporation will be less. So both the phenomena are possible. Number third factor is surface area of the liquid. Yes, surface area of the liquid is also affecting the evaporation rate. More area exposed to the environment will increase the rate of evaporation. This is because evaporation can take place only at the surface of the object. More surface area exposed to the environment will increase the rate of evaporation. When more surface is exposed to the environment, then it means more molecules at the surface will get chance to escape out from the surface of the clothes, and as a result we will get greater evaporation. That is why women are hanging the clothes and they are spreading it so more area is exposed to the environment. So remember that greater is the exposed area will increase the rate of evaporation. That is another factor we can see in the evaporation. Okay, the next is movement of air above the surface of the liquid. If the air blowing is high, then it means that evaporation will take very quickly. For example, on a very hot and humid day, if you are sweated a lot and suddenly you are standing beneath the ceiling fan, it means that the air blowing above the surface of your body is high, and the air blowing on your surface will give a chance to the molecules of the liquid to escape out from your body, and as a result you feel colder in the environment. Let me give you another example. When you are drying your wet hairs through the dryers. So it means that you are blowing air on the hair, which is a given, which is giving a chance to the molecules at the surface of the wet hair to escape out quickly, and as a result our hair will dry very soon. So another effect which is increasing or decreasing the rate of evaporation is the movement of the air above the surface of the liquid. Again and again I am saying surface of the liquid because evaporation is taking place at the surface of the liquid. So the next thing which is affecting the rate of evaporation is the pressure. Ladies and gentlemen, when we increase the pressure, it will decrease the evaporation. Let me give you an example. If you are putting clothes in those areas which are at high altitudes or at the mountain top, then the clothes are drying very quickly because the pressure of air is very low there. On the other hand, at the same condition, if you are increasing the pressure at the sea level, where the pressure is always greater, so the rate of evaporation will decrease. So another factor which can affect the rate of evaporation is the pressure. The last one is the nature of the liquid. In 2 or 3 lectures back, I shown you a table that this is the boiling point of this substance. If you observe that table, you will see that the substances which are having low boiling points can evaporate very quickly. For example, if we are taking the example of ether, whose boiling point was very low, so it means that ether can expand to the environment very quickly. It means that the lower the boiling point of a liquid, the high the rate of evaporation. That is why ether evaporate much more rapidly than water under the same physical condition. Remember these words. Water boiling point is greater than the boiling point of ether. So that is why the rate of evaporation of ether is higher than the rate of evaporation of water. On another hand, if you observe the mercury, whose boiling point is 375 degrees Celsius. So it means it will hardly evaporate to the environment under any condition. Under any condition, it can evaporate, it will not be evaporated to the environment. Ladies and gentlemen, these were the factors, and the last factor is saying that the nature of the liquid is also responsible for the increase or decrease of the rate of evaporation. Now, the final topic of this uh, unit is the household refrigerator, because evaporation and condensation is involved in the refrigerator. So that is why this topic is under observation in this unit. Ladies and gentlemen, this is the back of the refrigerator. Remember that refrigerator is using a gas which is called freon. Freon gas first is entered in this compressor in the form of vapors. When that vapors form is entered to the compressor, you can observe the compressor at the big compartment of the refrigerator. So this compressed the freon gas and converted it into liquid form and push it to these cooling tubes. These are the cooling tubes. The compressor is compressing the vapors form of freon gas condensed to liquid, and that liquid is pushed to the cooling tubes, and there are cooling fins that is removing the hotness of that liquid freon. These metal fins you can observe at the back of your refrigerator, but my advice will be not to touch any part of this uh, fins when the electricity is turned on to these fins, because it can electrocute you, and as a result they can damage the tissue of your skins, and that can cause death as well. So if you are not an experienced person, then you don't have to touch it. Okay, these are the fins, metal fins to dissipate heat to the surrounding. The freon gas and liquid form is taking to these tubes. The fins are taking out heat, and it is given to the surrounding environment. By which process? By convection. What is convection? What is conduction? What is radiation? That is our next topic. We will discuss that in greater detail. But the word used here, convection, is there, so I had to tell you that. So metal fins, these lines, vertical lines, dissipate heat to the surrounding mainly by convection. It is also written here that warm compressed vapor on the way to cooling tube with fins to be liquefied. It means that it will be converted to liquid. And after coming to this expansion wall, after passing the expansion wall, it will expands and the liquid freon will pass after this expansion wall and the temperature falls below 0 degree Celsius. When it is entering the ice compartment, which is the upper portion of the compartment which is making ice, that compartment is hotter than the liquid freons which is expanding. So heat will enter to the liquid freon because heat always flows from hotter body to the colder body. So when that hot compartment is giving heat to the freon gas, it evaporates. And when it evaporates, it makes the air inside the ice box compartment cooler. And the air as a result become heavier. And when the air become heavier, it will sink down to the lower compartment in which we are putting vegetable. It is not making ice, etc. So it will come down and make the environment colder. And what happened to the warm air inside this compartment is rises. And when it is going upward again from there, the cold air is sinking down, warm air is going. This process is continuous and all the things inside this compartment are becoming colder and as a result they are freezing. Ladies and gentlemen, let us take the advantage of time and telling you that we are putting ACs at the top of the wall, not downward, because AC is also utilizing almost the same criteria. So when the air becomes cold at the top, it is coming down and warmer air at the bottom is going upward. And again when those vapors becoming cool, they are coming down and this process is continuous. So that is why we are fixing the AC at the top of the wall. Similarly, this is also happening in the ice cube compartment. Colder air is coming down and warmer air is going up to be cooled down and then come back again and the this process is continue. Okay, when hot air inside the compartment is making this liquid freon warmer, then those are converted into vapors again, and these freon vapors are coming down in the form of the vapors again to the compressor, and again the same process is taking place to push it into liquid freon condensate, and again all that process is continue, and this is the whole process of refrigerator. Ladies and gentlemen, this freon gas is playing a very important role inside the refrigerator. Sometime when we are removing the freezed ice with a knife, and when we hit these tubes with that, the gas is getting out, and then the refrigerator will not work. So care must be taken while removing the freezed ice from this ice compartment, not to damage these tubes. Otherwise, gas will get out, and you have to repair that and put the gas, which is not only the loss of time but also losing your precious money. So while using the refrigerator, care must be taken to use it properly. Okay, ladies and gentlemen, that's it for today, because the chapter is finished, and tomorrow, inshallah, in next lecture we will do the exercise on these, which is very important. Exercise are designed very carefully. They are designed very carefully to test your knowledge you gained in the theoretical portion. So tomorrow we will solve different questions on these, which are of two types. One is called the MCQs, multiple choice questions, and the second is structure questions. So don't miss the next lecture. For that, you have to subscribe my channel, press the bell icon, so you will be informed immediately after I upload the video, and you will be the first person to see it. Thank you very much for your time. Allah Hafiz.